Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilations and measurements, specifically how dilations change the area and perimeter, and we will do it in 5 minutes or less. So we have just a basic rectangle, A, B, C, D here in our first quadrant of the coordinate plane, and I want to keep it simple. I want to dilate this, which means I need to do something with each of these coordinates with a scale factor. So let's start simple. Let's have a scale factor of 2. So what that means is I'm going to multiply all of these to get A prime, B prime, C prime, and D prime, and I'm going to just multiply each of these by 2, right? So I'm going to get 3 times 2, 3 times 2, which means it's really just going to equal 6, and so on. But before we really get into that, let's just make sure we understand what our perimeter and area is. And I made it really simple so we can just actually look at it here. So my perimeter is going to be 1, 2, 3, 4 on each side. So that's 8, 9, 10, 11, 12. All right, I have a basic perimeter of 12. And as you can see, I've just got 8 square units on the inside. So that's my area. All right, so I'm going to start plotting some of these, and what we're going to see is that when we dilate, I'm going to put that right there, that's going to be A prime. When we dilate these, it's going to change each of these in a different type of way. So when we dilate, our perimeter is going to change linearly. So what that means is it's going to be multiplied by the scale factor. And so look at this B prime over here. It's over at 14.6. It is way over here. But our area doesn't change linearly. Our area actually changes quadratically. We're going to have to square it. So let's take a look, see what our C prime is going to be. So we're going to multiply by the scale factor. It's 1410. All right, so 14, it's much bigger up here. So there's my C prime. And I can go ahead and start at least connecting those three. And then let me get my D prime. And that's going to be 3 times 2, 5 times 2, so that is 6, 10. And yeah, we're going to put that right there. All right, so there's my D prime. Now we have a much larger dilated shape. It's actually on a scale factor of 2. Here's the thing, let's see what happens when we check our perimeter and our area. So I'm going to call this perimeter prime and area prime. So my perimeter is going to be 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 8. That's another 8 down there. 1, 2, 3, 4. That's 4 and 4. So let's see. So 4 and 4 is 8. 3 8s make 24. So it's 24. So look what actually happened. So I doubled it because really what it is it's my perimeter times my scale factor. So my original perimeter was 12. And then my scale factor was 2. So when you dilate a shape, the perimeter dilates linearly. That means you just multiply it by the scale factor, whether it's by a fraction, whether it's by a whole number. The area is different. So check out what I've got here. I'm just going to see what my array is. 1, 2, 3, 4. So I got 4 up and 8 across, right? We already figured out the measurements on our perimeter. So that's going to equal 32. Now, how did we get to 32? Because it was 8 times 4, but the scale factor was only 2. Well, remember what I said, that the perimeter changes linearly, but the area changes quadratically. So what it is it is the area, the regular area, times the scale factor squared. So what we had to do is we had to take our 8, we had to multiply it by our scale factor, and then square the scale factor. That's why it's quadratic. So that's 8 times 4. That's where we get our 32. So this is going to be the one thing we need to learn from this video, is how these measurements change with dilations.